3 spacecraft, 1 destination, 0 successes. Billions spent, years burned. Not one of them touched the moon. And that's exactly why this story matters. Because space doesn't reward optimism. It rewards what survives failure. Late 2022, a suitcase-sized satellite slips away from Earth, heading for the moon. Its mission is bold and quiet at the same time. Shine infrared light into craters that haven't seen sunlight for billions of years, searching for water ice, something future lunar missions can't live without. The spacecraft is called Lunar Flashlight. It crosses nearly 250,000 miles. The moon fills its sensors. Now comes the critical moment. It has to slow down. 4 tiny thrusters are supposed to fire. Only one does. The others barely respond. With no way to brake, Lunar Flashlight screams past the moon and disappears into solar orbit. The mission is dead, but not useless. Even as it fails, it proves something nobody fully trusted before. A CubeSat can navigate deep space with precision once reserved for massive flagship missions. The autopsy follows. Contamination, design limits, tiny engines pushed too far. The fix reshapes how small spacecraft are built, tested, and cleared for flight. The satellite is gone. The rules it created are not. Now picture a spacecraft with no engines at all. No fuel, just a sail, thinner than plastic wrap, wider than a billboard, meant to ride sunlight itself. That's NEA Scout. It drifts into deep space. Then the command goes out. Deploy the sail. Nothing happens. They try again. Silence. No confirmation, no control, no mission. NEA Scout never speaks again. And the lesson is brutal. Earth tests are polite. Deep space is not. Vacuum chambers and simulations only reveal the weaknesses engineers know how to look for. Deep space finds the ones they missed. Radiation, thermal extremes, time. NEA Scout forces stronger deployment systems, better confirmation sensors, and designs that assume help from Earth may not arrive in time. It never reached its asteroid, but it showed the next solar sail how not to fail. January 2024, Peregrine lifts off, a commercial lunar lander carrying NASA instruments meant to mark America's return to the moon. Launch is perfect, separation is clean, then pressure drops, propellant leaks into space, power begins to fall, control starts slipping. Engineers watch it happen live. A lunar landing is impossible. Peregrine is redirected toward Earth, where it burns up in the atmosphere. But this failure talks every second. Telemetry shows valves under stress, power systems making impossible choices, control software fighting physics. The data forces design changes, testing changes, certification changes. Future landers will not be built the same way. Peregrine never touched lunar soil, but it made the next attempt harder to kill. NASA fails where everyone can see it. Signals cut out, missions vanish. What most people never see is what follows: the reports, the diagrams, the new rules written in telemetry and debris. From the outside, it looks like disaster. From the inside, it's how spaceflight evolves. These missions didn't succeed. They made success harder to destroy. This channel is about that side of space, the failures that shape the future, the mistakes that rewrite the rules, the missions that die so the next ones don't. Subscribe, because the next failure is already on the launch pad.